Today we're going to talk about converters and validators in JSF. Remember that the JSF lifecycle, which is absolutely crucial in terms of seeing where all the bits and pieces fit in, begins with an HTML form being submitted as a request to the web server. The web server will pass that request on to the JSF control servlet. Remember, we don't write the controller. And the control servlet will impose this lifecycle. So the first thing that it does is to build a component tree that represents the view that has just been submitted. And as part of that building of the tree, it will also populate the values from the HTML form. And it will populate it with valid values. That's the crucial thing here for today, valid values. Then it will take those valid values and update the model using them. And then it will use the valid values to update the model. That model is the backing bean and other Java classes. After the model has been updated, then it's time to start preparing the next view to render. And again, the view will have a tree, a component tree. So the control servlet will build a component tree for that next view and populate the elements of that tree, the UI elements, with values from the model. And once the tree has been prepared, then the next view can actually be rendered using the values that are in that component tree. So that's the life cycle. For today's lecture, the consideration really is, what is a valid value? Remember that the component tree and the model are updated with valid values. And in the context of today's discussion, there are two definitions of valid. First of all, of the correct type, that being defined by the business rules and will be handled by converters. So converters will ensure that the values are of the correct type. And the second definition of valid is that they have the correct value. Again, defined by the business rules and will be enforced by validators. And in the life cycle, this conversion and validation process will take place at the time that the component tree is built. The precise timing of this process will depend upon a setting called immediate. There's a property with each XHTML element, the UI components, that we can set to true or false. The default is false, so if we omit immediate, the assumed value is false. In every case, conversion is done before validation. So we'll take the HTML form values, which of course are just passed along as strings, and we'll convert those to values of the correct type. And after the conversion has taken place, then those converted values, which are now of the correct type, will be validated to make sure they fit the requirements of the business rules. If the immediate property has been set to true, then that conversion and validation will be done immediately, meaning that it will be done at the time the values are being put into the component tree. Otherwise, and this is the default case, the conversion and validation will be done after the component tree has been populated with values, but before the model is updated. So let's take a look at how conversion is done. Remember, what we're doing is processing the incoming values, parameters, from a request. Those request values are passed as strings. We saw that all the time when we were writing our servlet and JSP applications. And what we would have to do is if we wanted, for example, to have an age submitted on an HTML form, we'd have to take that age string and then convert it into an integer using integer.parseInt and make sure that if there was an exception with that conversion, we'd catch it and report the error. And every time we want to use an integer, we would have to do that. JSF does all of that automatically. So a lot of this low-level conversion, we don't have to worry about anymore. And what JSF will do is convert these strings to strongly typed Java objects that we can then use. So for example, if we were processing an age, it would take the string and convert it to an integer object. If we're dealing with a price, it would convert it from a string to a double, or maybe to a currency. And dates will be converted to date objects. If we're going to render a response, we need a conversion again, this time from those strongly typed Java objects to strings ready for output. And so there are two parts to a conversion. take it from a string to a Java object, and then from a Java object back to a string ready for output. And there are two forms of conversion, implicit and explicit. The implicit conversion will use the standard converters to automatically convert the strings to the appropriate Java object. This will work great for primitive data types. It will also work for java.math.bigdecimal and big integer. A little bit more about how that will work in a few moments. Explicit conversion requires us to write some XHTML elements or to write some custom converter classes. And I'll show you an example of all of those in just a few moments. Now, the thing about implicit conversion, which we might call automatic conversion, is that it can only be done if the type of the variable can be discovered. And that will be done via the value binding. If we've got an input text element in our XHTML, we'll give it an identity, ID equals age in this example here, value equals. If that value is bound to a backing bean property, then the type of value can be discovered, because we can go to the get method for that property, identify its return type. If it says it's an int, then we know that this string has got to be converted to an integer. If the return type is double, then we know it's got to be converted to a double, and so on. So the value binding, if it's bound to a property in the backing bean, will allow us to determine the type, and therefore implicit conversion can take place if it's one of those primitive data types, or big decimal, or big integer. There's an example of this in the standard converters project. Let's take a look at that. So in index.xhtml, we've got a whole load of things, amongst which is a question. How many siblings do you have? And then an input text. The ID of this input text is numsibs. Its value, and here's the crucial thing, is bound to a property in the backing bean. If we take a look at the backing bean, the getNumberOfSiblings method returns an int value. And because of that return type, JSF can work out that this string needs to be converted to an object of type integer. Now, if something goes wrong in the conversion, we'll get rather an interesting message coming out unless we put our own in. So we can put in an attribute as part of this XHTML element called converterMessage and specify our own. What I'm going to do for the moment is just take that out so that you can see what kind of message you would get if you didn't specify the converterMessage, and then run the program. So we've got this converter on number of siblings. I've taken off the converterMessage so that we can see what might happen if we put in an invalid value. Well, we know for absolute sure that nobody can have -1 siblings. So let's see what happens with that conversion. It seems to have accepted it, because -1 is an integer. That's okay. -1 will convert to an integer, no problem. So -1 is a problem only for the validation, and that we'll talk about a bit later. So what I'm talking about here is a conversion to the right type, not the right value. Let's put in something of an incorrect type. For example, we'll put in t. T obviously will not convert to an integer, and that will give us a very nice message, which is not something you really would want your end user to see. That is the default message provided by the standard converter. If you wish to override that message, it's very straightforward. Back in here, in the index.xhtml file, if we put in the converterMessage attribute and specify the text that we want displayed, now that error message has been replaced with our text, which is much better from the user experience. So that's how implicit conversion is done, not just with integers, but with any of the primitive data types, and also big decimal and big integer. Explicit conversion is done using one of 3 XHTML elements. There is a convertDateTime tag. This tag exposes the java.text.simpleDateFormat class. In other words, it's going to provide the same functionality that simpleDateFormat does. So we've got this input text that's bound to the userBean.dob property. So it's going to be a date of birth. And we want to convert that to a date time. So we use the f:(convert date time. Now f is a prefix which will be defined, as you'll see in a few moments, at the top of the XHTML file and is linked to the core XHTML library. There are several attributes that we can use here. All I'm showing in this example is the pattern, and we can use the standard pattern symbols for this. What we're saying here with this pattern is that we expect 2 digits for the month / 2 digits for the day / 4 digits for the year. I've just noticed a typo on that. That should actually be lowercase d's and uppercase m's. Notice that this tag, the convert date time tag, is nested within the input text tag. That's important. Also notice that if there is to be an error message for the conversion, it's going to be displayed here, and so we can identify the location of the message in our XHTML file. Now there's an example of this also in the standard converters project. So let's go right to the top first of all to look at the namespace. The namespace f has been made equal to this rather long thing, the JSF core. And copying pasting these lines is the best way of proceeding. With that namespace set up, when we're asking what is your date of birth, we know that whatever string they input needs to be converted into a valid date object. And so we're using the core tag convert date time to use that pattern, day, month, year. So that when we run this and we try to put in an invalid date, we will get an error message. Now the converter has generated an error message, a standard error message of the type that we saw on the previous example. So that error message hasn't been suppressed, it's just not being used because the converter message attribute has been specified. So the system has used our custom message instead of the standard message. If we then were to correct this date, then the conversion takes place. All those values are now considered valid. Therefore, the component tree has been updated. The model has been updated. The tree for the next view has been populated, and the next view has been rendered. So you see that the life cycle is completely halted if a conversion fails. And the original view is then displayed with the error messages. And we only continue with the complete life cycle if the conversion does not throw up any errors. Another of the XHTML elements for conversion is called convert number. And this will allow us to take a value and convert it into some kind of number using the decimal format class. In this example, we're using an output text element bound to a property in the backing bean, and that binding will then allow us to get a value. It's going to return a double value, and we want that double value to be displayed as a currency. In this example, we're using convert number and specifying type equals currency. So the double value will then be output as a currency. There are two other possible values for type, and that is number and percentage. I'll show you an example of this again in standard converters. Down at the bottom here, we're asking what is your salary? This is on input. With the conversion, we're specifying that it's to be a number, and it has a max fraction digit. In other words, how many decimal places can it have? 2. That will convert it to a number. All right? We're not converting it to a currency at this point. In the backing bean, we will get a double value with the set method, and we'll store that in a variable called salary. And then later, when we want to render the view, the salary will be returned as a double. In the response, which is the new view that we're about to render, if everything converts properly, we are going to output the date of birth. Again, we're using that convert date time tag so that it will be displayed in the appropriate format according to this pattern. And we're also, for the salary, using convert number, but this time instead of in the index we had type equals number, the very same value is now being displayed using this converter where type equals currency. So we're inputting it as a double, converting it to double, and then when we output it, we're taking that double value and converting it to a currency. When we run the program, if we put in an annual salary of £2,000 and 57 pence, you can see that the double value, which was stored in the backing bean as a double, has now been output as a currency. The currency will put on a symbol for the currency, in this case a pound sign, and it's also automatically putting in commas for every 1,000. We can specify what kind of currency symbol we want by using the currency code. We could also just specify currency symbol, but if you put in a currency code, that will override the symbol that you put in there. So if we put in a currency code and specify, for example, the standard code for euros, and then run this again, you can see now that the euro symbol has been used. The third explicit converter tag is actually called converter. And what it does is bind to a custom converter. In other words, this is going to allow us to write our own converter classes. And then we can use this converter tag to link to, bind to, that custom class. Now the standard date time converter will use the date class. But what if we wanted to use a calendar class? Since there isn't a standard converter for that class, we'll have to write our own. So instead of using the convertDateTime tag, we'll use the converter tag and specify the converter ID of the custom converter class. So in the custom converter project, in the index.xhtml, we can see that for the date of birth, we're now using the custom converter whose ID is calendar converter. And in the source packages, we can write this class. And the thing that makes this a converter is the annotation here. The @faces converter annotation will identify this class to the JSF environment as being a converter. Value equals, then we can specify the name. That's the ID for this converter. So as long as this value is the same as the converter ID in the XHTML, then this class will be used. Now conversion has two parts. Remember we said that when the incoming string is received, it needs to be converted to an object. And when we want to output that object, the object then has to be converted to a string. So there are two methods that we have. One called getAsObject. That's where a new value of type string is passed in as a parameter, and it gets converted to the correct Java type. And the other method, getAsString, will receive an object, might be an integer object, a double object, a calendar object, and that will then be converted to a string, which is then returned. So let's look at the conversion where we take a string first of all. We know that this string needs to end up as a calendar object, so in the method, we're going to declare and get an instance of the calendar class, and then set that time to be the new value. But what we're going to do is to parse that value using the simple date format object that has been declared up there and has been initialized in the constructor method. Not only do we set up the pattern for that conversion format, but by setting lenient to false, we're going to prevent things like the 32nd of December being converted to the 1st of January. When lenient is true, which is the default value, 32nd of December will actually become the 1st of January because that's the next day after the 31st of December. If you set lenient to false, then the 32nd of December will be rejected as an error. So we'll parse the string, new value, using that simple date format object, and if that works fine, then it will be used to set the time for the calendar. And then we can return that calendar object. On the other hand, if the parsing throws an error, then we'll throw a new converter exception. That converter exception then triggers the error handling process. It aborts the life cycle, the original view is displayed, and that error message will then be generated and displayed on the view. The other conversion is from object to string. So we're going to take this object, which ought to be a calendar object, because this is a calendar converter. So we're double checking, first of all, to make sure that the value, if it's null, will simply return an empty string. Otherwise, if the value is a calendar, we'll then take this calendar and use the simple date format object to convert it into a string and return that string. Otherwise, we've got an unexpected type and we'll output an error message to that effect. So all the converters you write will have those two standard methods. And all you've got to do is take a string and return the appropriate data type, or take that data type and return it as a string, depending on which method you're writing. And then we can use that converter in this fashion. Quick demonstration. Let's put in the 32nd of the 12th, 2015. And because setLenient is false, it won't allow that. And if we put in 31st, it's quite happy about that. Another way of linking to the custom converter, instead of using the convert tag, is to use the converter attribute inside the UI component, and that works in exactly the same way. We've talked about these error messages. We can override the standard error messages by using the converter message attribute.